Okay, so first, pardon the mess in my workshop. I've started building uh, the wing, and as you can see, I'm gluing parts together. I'm gluing actually the wing together. So these are basically 1, 2, 3, 4 parts. 2 parts here, this part of the wing, and then the vertical stabilizer. I still have one more part for this side of the wing, which is basically this one. So after this is glued, I'm gonna glue this part, and then the last part of this wing goes here, like this. So you have this shape. Okay, and then the other wing is also being glued. After I finish gluing the wings, I'm going to basically finish the servos. So as you can see, we have a servo pocket here. I've already put the servo in, cable coming out from here, and I'll fix the servo cover, and then we'll move to basically gluing the body. It's simple. I mean, the gluing isn't complicated. You just need to insert the bars here, the wing spars, to make sure that they are properly aligned. So the assembly is progressing really well. You can see that this wing's almost done. I've glued the wings together. I've put the servos. I've routed the cables to the fuselage. This wing is almost done. I'll just maneuver the airplane to show you. So I've glued all the parts together. What I'm only missing here is the aileron that is printing right now on my 3D printer. I'm going to basically now also glue the other side, the other part of the wing here, which is this one, and then we'll be done with the wings. It's then just a matter of connecting or basically gluing the ailerons, and then connecting push rods to the ailerons. It's progressing really well. It looks really nice. You can see the vertical stabilizers. You can see how much space you've got inside. This is the front part, and as you can see, when I put them all together, this is going to be the final size of this wing. Really impressive. The only thing that is a little bit off my calculations is the weight. I was expecting this to be around 900 grams dry weight, which means weight without electronics. I think it's going to be around 1,000, maybe 1,000 something. So the total weight I approximate with the electronics and the battery will be around 1,600 grams, 1.6 kilograms. So it's going to be really challenging to hand launch this. The safest way to do this is with a bungee launcher. Just look at this wing profile, or basically the way the wing looks. It's going to be a really fast wing. Very nice thin airfoil. Okay, so I'll keep putting this together, and I'll keep recording videos. I'll compile the video, and then you'll be able to see how this thing looks like when I'm done. Okay, so the wing panels are now complete. So as you can see, each wing has 1, 2, 3, 4, 5 pieces, plus 2 pieces for the aileron, and then we have 1 vertical stabilizer. I've also installed servos, a servo and a servo pocket. It came together very nicely. You have holes or channels for the rods, for the spars that you put in. So the spar will go in here and then go through to the second panel only. The third panel has another like small channel for a spar that you can put to connect the second to the third panel, and you put some glue and it's going to be a really solid connection, and then you connect the fourth panel with glue. Each aileron, or basically this aileron, is two pieces. You glue them together, you have slots for the flexible joints, you put the slots, you put the flexible joints in, you CA glue them, and then it comes together very nicely, as you can see. This is also the second one. Same story, you know, came together very nicely. The only basically issue I faced was that the designer made it in such a way that the two pieces for the aileron have the same length as the gap between this last part, or this line here, until the vertical stabilizer, which means whenever you want to deflect the aileron up or down, it's going to bind with the vertical stabilizer. So what I've done is that, I don't know if you can see here, I've made a clearance between the aileron and the vertical stabilizer, so that when the aileron moves it won't bind with the vertical stabilizer. And that meant also that I had to cut this section of the aileron here a little bit short, otherwise it would bind with this section of the wing. No major issues in putting these together. The two wings are done now. What I'm going to do basically now is complete the fuselage. So I'm still waiting for the motor. I should get it tomorrow. The motor goes here in the back. I'm just trying to find the firewall, and here's the firewall. So the motor goes into this piece. There's like 4 holes in the back for the firewall. You basically screw the motor to this firewall and you put it here in the back. You have 4 screws to mount the firewall to the back, like this. And then this piece goes in here. Now this piece, which is in the back, just needs glue because it's supported by the main spar that goes in here, and supported by 2 spars basically going here and here. So when you basically put glue here between this section and this section and you put them together, they're held together also by the spars here and here. So there's no need to fortify or basically reinforce the connection. What I have to do is reinforce the connection here between this section and this section. I'm going to use basically carbon fiber rods, 4 pieces at 4 different points, here, 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 and here. From the inside, of course, I'm going to basically put a carbon fiber rod and glue to basically reinforce the connection between these 2 pieces. What else? Then after that, I'm going to be basically working on the nose. I'll need to find a way to mount the DJI FPV camera and air unit here in the front, which I have ample space for. I'm just trying to think as of now how to mount or how to basically mount the antennas in such a way that they're sticking out. Most probably I'll 3D print a plate that's a little bit high here so that the antennas can go out from here and here. This is turning out to be a very nice project. I'm really enjoying building this plane. The weight is a little bit more than what I expected. Let me put up the scale. So if you put the scale here, you'll see that. Sorry for the mess. I'm going to put these together. I'm going to use the spar, I'm gonna put the spar here, I'm gonna put it through, sorry, and then I'm gonna connect the first wing. I'll then put the second piece here. I'll make sure that the spar passes through as it should. So the first wing is mounted, as you can see here, and then I'm going to take the second wing and I'm going to do the same thing. I'm going to mount the second wing. And now you can see it came through together in a very nice way. I'm going to put it on the scale to see how much it weighs. So the scale is reading 1016 grams. I'm going to be basically putting the nose cone. I'm just going to put it here. So that's 1048 grams, and then I'm gonna put the small firewall, if I can find it. Here it is. I'm gonna put it here. So that's 1050 grams, and I still have to print 3 covers. So the total, I think the whole the dry weight is gonna be 1100 grams. That is why I think with electronics, with a motor, maybe 1500, 1600 grams. Yeah. Okay. Okay, so the build is complete, and let me show you what I've done. So all those parts are part of the design by the original designer on Thingiverse, except a couple of things that I've done myself, and I will go through it with you. Let me first start with the construction. So all this has been glued together with a glue called E6000. It's a very powerful glue, and it doesn't take a lot of time to set. I've used it throughout the plane, and it performed very well. And the wing itself takes 2 types of wing spars, a 5mm and a 6mm. A 5mm and a 4mm wing spar, like these. You can get these from any hobby shop. This is the 5mm, and this is the small 4mm carbon fiber rod. It came together with glue, with spars, and it's very rigid and strong. Now, on top of the design, or basically the parts that you will find on Thingiverse, I've added a couple of parts that I've designed myself. So as you can see, this model is closed, so there's no way to have air circulate inside, and I had to find a solution. So I designed an air inlet at the front, and the same part can be placed in the back here, which is an air outlet. This way, as the wing flies, air is going to come inside from the front and go out the back, and will be able to cool the electronic speed controller and the DJI FPV, digital FPV system. I've also made this antenna mount that you see here. This antenna mount, it's also 3D printed. I designed it myself, and it can take 2 R9 or Immortal T antennas from Crossfire, either the R9 antenna from FR Sky, or basically the Immortal T antenna by Crossfire. I'm currently using an R9 mini receiver with 1 antenna. In the future, if I upgrade to the R9 SX, which is a dual antenna receiver, I can put the second antenna here. The third thing actually that I've done is And as you can see here, I've also printed a hook at the front. The reason is I want to bungee launch this wing given its weight, and this hook is a perfect, you know, part for bungee launching. Let me take you through the inside and what I've done on the inside. So, or before going to the inside, let me talk about the hatches. It has 3 hatches, one here, and one in the back. And the way I secured them is a tongue and groove design. So as you can see, I've put another piece of plastic underneath the cover, and then this piece of plastic goes inside into the hatch and then locks in the back with a magnet. As you can see, there's a magnet here. I glued a magnet on top, and then as you can see, there's another magnet underneath. So basically the canopy latches through magnets, and it's quite strong. Same thing for this hatch, same thing for the second hatch in terms of the magnet, and also the third hatch. Let me remove the hatches and then show you what's inside. I'll start, basically, let me position the plane properly. I'll start with the rear hatch. So you can see I've put a 30 amp electronic speed controller. The wires from the motor go inside from here, and they connect directly to the electronic speed controller. Nothing fancy over here. And then opening the second hatch, you can see here that I've put a Matek F765-Wing flight controller. I've loaded Arduplane on it, and I've fully configured it. It's ready to fly. I've also placed a GPS unit, and I wired it to the flight controller. And I don't know if you can see it here, it's a little bit tight, but here's my R9 mini receiver wrapped with a red heat shrink tube, and the antennas coming out from here and all the way to the, the antenna cables coming out all the way to the antenna. In the front, I've printed, again, this is something from you'll find on Thingiverse. It's a simple, battery tray that I've printed, and I glued here again with the E600, and I've put some shelf liner layer so that the battery would stick to the battery tray. What maybe you cannot see here is inside. I've basically, I don't know if you can see it, but I've put the air unit inside. So if you look at the front, you will see the camera. This is the DJI digital FPV camera, which connects directly via wire to the air unit. I don't know if you can see it here. Sorry, the lighting isn't very great, but this is the air unit, and from the air unit I have 2 cables for the video antennas coming out, and as you can see, I've connected 2 LHCP Omni antennas to this part of the fuselage, and then they connect directly to the air unit. I drilled 2 holes basically here, and here, and I was able to mount the antennas. So everything has been complete from a design / configuration perspective. I've even used an online CG calculator. So you basically punch in the wing dimensions, and it tells you exactly where the CG is. In my case, it turned out to be 10 centimeters from the leading edge here. So as you can see, I've made 2 black spots. I'll paste a link in the description for that, CG calculator, so that if in case you wanna build this yourself, you can use it. If you don't want to use it, I'm just telling you it turned out to be around 10 centimeters from the leading edge. So next is basically to try and fly this wing. The all-up weight with the battery is 1.8 kilograms. When I say battery, I mean a 3400 4S battery, which is quite big. The reason is I use this, I mean, usually I fly wings long range, and a 3800, I meant a 3800 4S. The all-up weight is 1.8 kilogram. The reason is I fly this wing long range, and with a battery of a 3800 and this 2216 motor in the back, the plane would fly between 30 to 40 minutes based on your throttle management. What else? So yeah, I'm gonna paste the link for the CG calculator in the description. I've also pasted in the previous video the link for this wing on Thingiverse. I'll paste it again in this video. Wish me luck. So I'm gonna go ahead and bungee launch it. This motor will give you around 1.2 kilograms of thrust with a 9x6 or 9x5 propeller. If you like this video, if you like the information that I've presented, please click on like and subscribe. And if you would like to support this channel, please do consider purchasing your FPV gear from the shop that I will also put a link to in the description. Thank you, and the next or the third video will be basically the flight video. Wish me luck.